Sir, I would like to welcome you as well and our audience. So, hello, good evening, everyone here. So, I'm Moini Shukla, your host for the today's session, and I work as science communicator for ScienceOverse. Heartily welcome you all for the session. And we have session today as solar atmosphere and its effect on our environment. So, and if anyone in case leave the session, so they can join from the same link again. So before introducing our guest, I would like to explain about what ScienceOverse do. So ScienceOverse is a scientific community for all science enthusiasts with a vision to provide resources, awareness, and support to all science enthusiasts and the upcoming generation to pursue a career in any science field. One of its objective is to build an educated society by enhancing the scientific mindset among the new generation, as well as to develop human race and nature in the scientific manner. If we will see till now, we have provided services in almost every field of science. There are many webinars and sessions that we have conducted for free and for all science enthusiasts. So we currently have two projects in progress. In addition, we organize competitions and events to create more awareness about the science and make it popular among the youth. And now I would like to introduce our guest speaker, Mr. Sanjay Yadav. Sir, Sir has done his BSc and MSc in astrophysics from Delhi University and currently pursuing his PhD in astrophysics from the University of Petroleum and Energy Studies. He also knows some of the coding languages like C, C++, and Python. And today he is going to share information about the solar atmosphere and its effect. So I heartily welcome you, sir. Now you can take the session. So we all are waiting here to get some more information about the solar atmosphere.
Yeah, thank you, Mohini, for giving me opportunity about to discuss to solar atmosphere because it's very important to learn about these effects of atmosphere, solar atmosphere. So I'm gonna start. If anyone wants to join, you can do as fast as possible. Okay, so the whole presentation is about solar. What is a solar composition? Means what is inside and what is outside the sun. We are looking at what are the gases and how we are getting energy from the sun. And the next part is source of energy, how we are getting energy, and what is the factor costing for energy release in sun. Okay, so and the next part is solar atmosphere, which is most important because atmosphere of sun is it's beyond Pluto also. That means we are in the atmosphere of sun also. So that means there are some effects of atmosphere or we are facing in daily life. Next, we will talk about the formation of atmosphere, means what causes the atmosphere to have sun have. Just like Earth have atmosphere because of Earth gravity and Earth gases combination also. But sun has atmosphere because of something different. Okay, we'll talk about the formation of atmosphere, how it is formed, and the next part, which is most important in our presentation, is effect of solar atmosphere on Earth. Okay, so let's start with the first component, solar composition. Okay, so solar composition consists of first part is solar radius, means its size. Its size is about 109 times radius of Earth. Okay, that means we can reside 109 Earth in our sun. Okay, so how big is this? We can consider it from the solar radius. Okay, so next part is solar luminosity. Luminosity, what is luminosity? Luminosity is the energy released per second by our sun. So how much energy is released by sun in 1 second is approximately 3.9 into 10 raised to power 39 ergs per second. Ergs is the CGS unit of energy. We know about that CGS unit of energy. This is the luminosity, means this is the energy release in 1 second. So you can consider, you can imagine how big amount of this energy is released by sun in 1 second. And we will discuss about how this energy is released by our sun. Okay, so next factor is surface temperature. What is the surface temperature? These are some parameters I am discussing, and we'll discuss more about them. So you can remember also it's these factors also. So first is third is surface temperature. Surface temperature is 500 5770 Kelvin of this is the temperature of surface of sun. Okay, and the next one is central temperature. How big amount is this central temperature? You can get from this parameter 15.6 million Kelvin. That is million Kelvin. So how big amount of temperature is there in the center of sun, and which caused many factors also. We'll discuss more about the central temperature, what it affects on our center, and what causes to release energy by our sun. Next is solar mass, the mass of our sun. These are the standard parameter which are determined by some theoretical calculations, because we can't calculate these from observational part. These are considered by theoretical calculation from observations. Okay, so solar mass is around 2 into 10 raised to power 30 kilogram. So we can consider, we can imagine how big mass our sun consists. Around 99.8% of our whole solar system consists of sun's mass. Okay, and the next part is surface composition, means what are the gases on the surface of our sun. Around 73.5% hydrogen gas resides there, which is most important because all the planets and all the stars are formed by hydrogen gas. We know that about hydrogen gas is the most abundant element in our universe, right? So around 73.5% hydrogen consists on the surface of our sun, and the rest of the elements like helium. Helium discovery is from our sun, because helium sun consists sun name is formed from the Helios word, which is a Greek word for helium. Okay, so Helios is the name of sun, which is derived from helium. That is, helium is discovered first from our sun, and later on from the earth we can calculate, we can find helium on surface of earth also now. uh, but initially it discovered from our sun. Around 44.5% reside on the surface of sun, and the rest of the elements like carbon, nitrogen, oxygen, ferrous, and nickel also present on the surface of earth, on the surface of our sun, around 2%. Okay, and the next question is comes from our mind, that how we calculate these parameters, because we can't go there, we can't calculate these parameters from so these parameters comes from the calculation part. Okay, we can get only spectrum from our telescope, and rest of we can decide from the spectrum which hydrogen lines and which helium lines are we are getting from the spectrum. Okay, so we can get these elements from the surface of earth, surface of our sun. But in central we can't get spectrum from the center of our sun. So how we get these parameters? So these parameters are just imaginary points. These can be changed, but these are just imaginary, because we are getting how much energy we are getting. From this, we can imagine how much percentage of hydrogen and helium present in our center of sun. So these are the imaginary points, because we can't these parameters. We can just calculate from the factors just like luminosity and temperature of our surface of sun. From these parameters and from spectrum, from these or from all these parameters, we can calculate the central composition of our sun, right? And the next important point is average magnetic field of photosphere. What is photosphere? Photosphere is the outermost layer of our sun, which are visible from our naked eyes also, which are seen by our naked eyes. So the average magnetic field is around 1 gauss, and sun as well as on earth also. So its average value is around 1 gauss, right? So we'll discuss more about the magnetic field of sun also, because it's a most important parameter in considering in making solar atmosphere. So next important point is 4.5 billion years of solar age. After 4.5 billion years, sun will burst. Okay, it will go because every star died after some interval of time. So this is the interval of time. That means solar age is around 9 billion years total age, but it covers around half age of this solar time cycle. So after 4.5 billion years, it will blast and it will become a white dwarf star. That is, no energy will get about after that, and it will if we get one uh, pen amount of anything from the white draft, it will weight around one car on the earth surface.
नहीं लिंक कौन सा है वही जो अनऑफिशियल में आ रखा
Okay, anyone, please switch off your mic.
Sir, you can continue. I have muted that.
Okay, so the next parameter is central density. Density is the mass per unit volume. That is, this is combination of gases per unit volume. How much amount of gas is present in the center of our sun? It is around 8 times gold density. So you know about the gold. That means how much dense is our sun uh, near the center. That means 8 times gold density. But from this density we can't consider that it is made of solid, because there is large amount of temperature and pressure present there, which makes the gas, which makes a solid converted into gases. So we'll discuss more about the center, and next continue, we'll get the surface density is around 10 raised to power minus 5 times air density present on our surface of Earth, which is around 1.27 kilogram per meter cube at 0 degrees Celsius, and 1 atmospheric pressure is present on surface of Earth. So this is the surface density. So you can consider, you can imagine how much low amount of density, how much low amount of gas is present on the surface of Earth, right? As we are getting 8 times gold density in the center of our sun. So the last parameter is Earth Sun average distance. You know about the astronomical unit is the parameter, which means 1.5, around 1.5 into 10 raised to power 11 meter. It is the standard value of Earth Sun average distance, which is known as astronomical unit. Okay, so the last parameter is type of star, which is not relevant for all the students, because there are a lot of types of stars present in our universe. So I am telling about little bit about this. So our sun is a main sequence star, means it is a stable star, means it is neither expanding nor contracting, means gravitational force is balancing our pressure energy is balancing by gravitational energy. Okay, so So these slides consider these slides tells about whole what I have told about the sun. So the next parameter I am telling you about the photosphere uh, core and the convective zone, which is the outermost layer inside the sun, and the prominences will discover more. Will tell you about more about the prominences and chromosphere and so radiative zone is what is radiative zone? Radiative zone is the zone from the center of sun to around zero point 0.7 solar radius. Solar radius is around 6.9 into 10 raised to 5, 10 raised to power 5 kilometer, which is the radius of our sun. So around zero point 0.7 times radius of our sun is consist of our radiative zone. Means because of large temperature and large pressure, the whole inside our sun is consist of all the gases, because at such a large temperature nothing can sustain as a solid or liquid part. Okay, so this is the radiative zone, means all the gases, all the material present inside our sun is gas around zero point 0.7 radius up to 0.7 times solar radius. Okay, and this is our distance from Earth to Sun distance, and this is the time we are getting for sunlight to reach from Sun to Earth. It is the around 8 minutes and 20 seconds. So I have told about all these parameters earlier. So this picture told whole the slide which I covered initially. So next parameter is what is the source of energy in our sun? So we know about the hydrogen, most abundant element present in our universe. So that is the building block of our sun, as well as planets, as well as all the human beings are made of from the hydrogen gas, hydrogen elements. So in sun also there are elements of hydrogen. I told about around 35% of hydrogen present in our sun core. So let's consider this equation, this reaction, two hydrogen elements. These are only ions, because at such large temperature, nothing, no atoms can survive. These atoms will ionize and their electron will go in uh, in the reaction. They just be I mentioned here as a positron. So two hydrogen nucleus, which are protons, we can consider. So two protons can combine to give a deuteron nucleus, deuterium nucleus, we can call it deuteron as. So we'll get a positron and a electron neutrino from there, and this deuteron will further combine with a proton to give a helium isotope from there. And from the same reaction we are getting from the uh, this slide, and two helium isotopes, three helium isotopes. From these two helium isotopes will get a helium nucleus from there. Or and there are a lot of energy release, which are I mentioned here gamma ray. So gamma ray is the main part of this energy release from these whole reaction. So how we are getting energy from our sun is four hydrogen elements, two hydrogen is there and two hydrogen is there, four hydrogen uh, nucleus combined to give a helium, to give a alpha particle. We can call helium nucleus as an alpha particle, and enormous amount of energy released in each reaction. So what is going on this reaction? So we can consider this part of this reaction is deuteron, and there is a neutron, and there is a Deuteron consists of one proton, one neutron also. Means proton is converted into neutron plus positron, and this is electron neutrino. Neutrino is very, very important for understanding center of our sun. Also, but I'm not going for in detail also. So, proton to give a helium, four protons to give a helium nucleus. How they are fusing? Fusing means how they are combining with each other. So there is a factor like kinetic energy of protons. This kinetic energy is very, very high because of a very high temperature present inside the sun, near the core of the sun. So this overcome our electrostatic repulsion because we are known that protons are charged particles, positive charged particles, and there is a repulsion between these two protons, and the repulsion will balances by the kinetic energy, enormous amount of kinetic energy because of the high temperature around 10 to 18 million Kelvin. I already told about 15.6 million Kelvin temperature present near the core of the sun. Okay. So in 1 second, how much energy released by which I told about a solar luminosity that is 3.9 into 10 raised to power 39 ergs, which is released by our sun in 1 second. Okay. So there are around 5 it's a temperature in the base of photosphere. Photosphere base means around 500 kilometer depth from the surface of our sun. Its temperature is around 6500 Kelvin, and the outermost part we are seeing that 4400 Kelvin temperature present there. Okay, so we can consider the effective temperature of photosphere is around 5770 Kelvin. Okay, so next part is base of the photosphere is a patchwork of bright and dark region that appears and disappear, which is called granulation. Granulation is means form into grains. This we can see from this image. There are a lot of grains like structure present in the surface of our sun that is called granulation, and these grains, these patchworks, bright and dark spot will rise and down with respect to time. This is given the characteristic lifetime is around 5 to 10 minutes. And the spatial scale means its distance, it's a distance in of sun. It's just like we make tea and just boil it in the last procedure of tea making is the boiling of the tea. So there's the same pattern we are observing in our surface of sun. So you can see from this video the surface of sun is boiling. It's extend around 500 kilometers, and the spatial scale of each patch is each bubble, just like a tea boiling process. Each bubble consists around 700 kilometer spatial scale, and these loops are known as prominences. This is the next part of the slide, will include prominences part, and you can see the loops here in this video, and You can see bright and dark patches, which is known as granulation, and this hole is known as sunspot. From the magnetic field lines are rising from the surface of our sun. So this is the whole loop. It extends around 700 kilometer in total. Okay, so we'll discuss more. The next layer of our sun is chromosphere. The first layer is photosphere, which will be seen, which we can see from the naked eye also, but it's very harmful to see from naked eye. You can't have you don't have to see. Okay, so we'll more discuss the chatting part next. The next layer is chromosphere. It's around intensity. Intensity means visible surface. Visibility is around 10 raised to power minus 4 of the value of the photosphere. That means we cannot see the chromosphere without covering the sun surface from any filter. But by covering the sun's total sun from the any filter, we can see the chromosphere part, and the next part, which is most important, the corona part also. So it extends around 2300 kilometer from the surface of our sun. And the gas density means number of particles per unit volume is decreases from the surface of sun to around 10 raised to power 4. That means if the gas density is around 1, so gas density in chromosphere is around 10 raised to power minus 4. That means a very low density in the chromosphere, right? And temperature, see, this line will be most important for everyone. Temperature begins to increase from 4400 Kelvin to 25,000 Kelvin. So why there is increase in there is sharp increase in this temperature? This is the most valuable problem for astronomers to discover it. So we'll discuss more about that. And the last one is speckles. Speckles you can consider as spikes. Spikes in you know about the spikes also. You can just see from this image. See, there are spikes. There are a lot of spikes in our sun's surface. These are known as speckles or filaments or vertical filaments. These extend from around 10,000 kilometers. And in this lies in chromosphere, in the second layer of our solar atmosphere. The next part is these speckles has lifetime around 15 minutes. 15 minutes means these spikes will be seen around 15 minutes, and there will be another spikes, and there will be another spikes in 15 minutes interval of time. And there are 30,000 speckles may exist at a given particular given time. And they are erupting mass. They are erupting gas particle from the surface of sun, and their speeds is around 20 kilometer per second. Means the particle which are emitted by our sun, whose speed lies around 20 kilometer per second, comes under the speckles category. And there is a more also, and there is a category like solar winds whose speed around 200 to 700 kilometer per second, which will be effective in our surface of Earth. I will discuss more. And the next part is prominences. Prominences, I already told about the prominences. Prominences are the loops. I have seen these loops in video. The loops consist of two holes which are known as sunspots, and which can be seen from any filter. There are because holes are always in even number, because their loop always consists of two loops, two holes. Loop will be formed from the two loops. So prominences can reach up to 1 10 raised to power 5 kilometer. Up to 10 raised to 5 kilometer loops can be reached. But what are the uses of this loop, and what they hazards our atmosphere. So you can see from this image, there are loops in this, and these are known as prominences. And there are speckles we can see from this is the solar flare, and speckles are not seen in this image. You can see only prominences in this image. And this is our sun, this is our earth, which face these solar flares and the high speed solar wind particles also. So the next important part after the chromosphere is transition region, and the last one is corona. This is a most important transition region because in this region there is sharp increase in the temperature, around 4,400 Kelvin temperature on surface of Earth, that is photosphere, and around 50,000 Kelvin, and then 10 raised to power 6 Kelvin. There is sharp increase in temperature, and we can just observe from the UV lines 116 angstrom Lyman alpha emission line, which can be calculated that chromosphere has temperature around 20,000 Kelvin and more also in million Kelvin. You can see from this graph in this curve that there is a sharp increase in the temperature as we go above around 2,000 kilometer from the surface of sun to around 3,000 kilometers. So there is a sharp increase in the temperature that is called as a transition region. So why there is a sharp increase in this temperature, and there is a large amount of temperature present in the corona as compared to surface of sun, which is known as coronal heating problem, which is most common in today's life. Coronal heating problem. We don't know about how we are getting such a high temperature in corona. There is a gas only. And what is that gas? I will told about that. So the last part is in our atmosphere is the corona. The corona can be seen from the eclipse only, eclipse, solar eclipse part. And by covering the sun surface, by covering the whole sun, we can see the corona part of our sun. It's around located above the transition region. I already told about the transition region, and it extends to several solar radiates. It comes near the surface of Earth and other planets also. It has energy around 10 raised to power 6 times less intense than in photosphere, and we can see only photosphere part. So its intensity is around 10 raised to power 6 times less intense. Means we cannot see this corona without any eclipse or covering the sun surface. And the next part is density, very low density, around 10 raised to power 5 particles per cc. And we know that 10 raised to power 9 particles per cubic centimeter present at the sea level. At the sea level, there are 10 raised to power 19 particles present in the gas. So there are only 10 raised to power 5 particles present in 1 cubic centimeter volume of gas. So there is a very low amount of particles present in that corona part. So this uh, how we know that this corona have large amount of temperature? We can calculate from the Ferris line, which indicates such a high temperature around 2 million Kelvin temperature present in the corona part. So such a high temperature, how we are getting such a high temperature? So all the atmosphere are formed from differential rotation of sun. What is differential rotation? As the name suggests, differential means every part of our sun, every altitude of our sun element, every circle in every altitude of our sun has differential rotation. Means we can just see from this image, there are around 25 days solar rotation near the equator and 26 days above the equator and around 35 days near the poles of our sun. So that means gases present in different altitude have differential rotation, different rotation period. So all of our atmosphere is formed because of all these parameters. I already told about specules, which are spikes in our sun. And next one is prominences, which are loops. And the next part is most important today's life, solar wind. And the last one is coronal mass ejection, which are ejected from the coronal holes also. Most importantly, these ejection are held near the poles of our sun. So, what causes differential rotation? Means how a differential rotation formed atmosphere or sun. So, due to differential rotation, we know that sun have magnetic field also. So, how this magnetic field is formed in sun? Because of the ions present in our sun, and there is a rotation of ions. That means they are producing current, and if current is produced, that means magnetic field is produced, and this magnetic field is distorted because of differential rotation of sun. And how these magnetic field lines are distorted, we can see from these three images. This is known as Babcock model. So these magnetic field lines, we can see from these images, these magnetic field lines are bent and bent and bent, and there are emission near the equator. You can see from this image, there are loops formed near the equator. So these magnetic field lines are emitted near the equator, and they consist of enormous amount of gases, and they will spread in the atmosphere of sun, and they will form as a solar atmosphere. So the whole atmosphere of sun is formed from the, I think, differential rotation from the sun, and magnetic field lines distorted from the sun. This is the whole concept behind these atmosphere formation of our sun. So next part, you can see from this image, there are many loops present in each part of our sun. You can see near the south pole there are black patches. These are known as coronal holes, and in north pole you can also see a black patch. These are known as coronal holes, and these loops are known as prominences, and these are formed from the magnetic field lines distortion, right? So the last and important point is effect of solar wind. If a solar wind, how solar wind is formed? I told about the prominences, the loops formed in near the equator, and these loops form these loops eject many particles, and also spikes and spicules near the poles ejects many gas particles, and which moves with a high speed around 200 to 700 kilometer per second, which is known as a solar wind. So this affect our atmosphere of our earth or any other planets like Mars is totally affected from the solar wind. I will told more about that. So satellite communication will be disturbed from the solar wind if a very high amount of solar wind comes from our sun. And the next important part is solar wind is blasting earth oxygen, which is a major problem for human beings, because oxygen is a building block of our human beings, because without oxygen we can't live in earth. So solar wind is blasting earth oxygen around. We know that uh, in solar wind there are charged particles like protons, electrons present there, and these protons have energy around 10 raised to power minus 16 joule near the surface of our earth. And the escape energy means energy required for one oxygen molecule in earth atmosphere is around 10 raised to power 18 joule. Means higher the amount of this energy will escape this oxygen molecule from the surface of earth. So 10 raised to power 16 joule is more than 10 raised to power 18 joule. That means 120 oxygen molecule can be escaped from a single proton. Okay. And then the next part is satellite can be destroyed also. and the last one is can increase earth temperature also, because earth temperature depends on solar activity also. There is a terms called Maunder minimum around 645 to 700 1715 years. These are the time period of around 75 years in which earth temperature is lower than other years. This is called Maunder minimum, because in this time period sun activity is very less, around 75 years interval of time. So the major problem of solar wind is blasting earth oxygen and the satellite communication disturbance, right? So this second parameter is blasting earth oxygen is very useful in case of Mars, because Mars does not have any magnetosphere, means it does not have any magnetic field, because we know that magnetic field charge particle behave, charge particle path changes according to magnetic field lines. So in Mars there is no magnetic field. That means one proton will escape around 120 oxygen molecules. So all the oxygen is escaped from the Mars surface. So initially we know that Earth, Mars have water also, oxygen also. Its surface is just like our Earth, but it is destroyed by solar wind. This is the main theory behind solar wind. So you can see this image. There are solar wind particles coming from the sun, and this is the magnetic field of our Earth, which which try to stop charge particle, and which deflect charge particles. Also, we know that there is a deflection in there is a deflection in charge particle path in magnetic field. There can be circular path, there can be elliptical path, and there can be main straight line path also. So we know a terms boreals and australis. These are the two terms which can be seen in the North Pole and South Pole. Aurora means polar lights. Polar lights, there are two poles. We know that in the North Pole and South Pole in the Earth. And there are two types of lights we can see many times on Earth, on the poles, which are known as Aurora borealis and Aurora australis. Australis means southern surface, and borealis means northern surface. The next part is also a very important moon. There is also a theory, there is also a research paper that says about a moon surface have also oxygen. How moon have oxygen present in the atmosphere? So main theory behind it is the oxygen escaping oxygen particle, the earth escaping oxygen particle, and they reaches from earth to moon, from the solar wind to moon. So this is the solar wind particles. Okay, so wind, and this is the our earth, and moon is just behind earth in the rotation around earth. And in this time period the solar wind will come and escape energy, escape oxygen particle from this part and this part, and these oxygen particle will go to moon surface, because the moon is the next part which absorb the oxygen molecule or any gas molecule, because a moon also have some gravitational force also. So moon attracts these oxygen particles, and we can see, we can observe the traces of oxygen particle in moon surface also. So the theory behind the moon have oxygen particle is the magnetosphere of our Earth and the rotation of moon around Earth. So the whole presentation is saying about the atmosphere of Earth, how Earth atmosphere is changes, or how the moon getting oxygen from the Earth, from the solar wind, from the sun. So whole presentation is telling about these two parameters. So Earth atmosphere is disturbing by solar wind, whose speed is around 200 to 700 kilometer per second. And these solar wind uh, also going beyond the Pluto also means this winds also changing the atmosphere of other planets also. I already told about the Mars atmosphere, which is destroyed by solar wind, and there is a theory behind that. And this is the whole presentation I have told about that. If you have any question, you can ask me directly. Okay, Kesav Kumar, what is your question? You can ask me.
Good evening, sir.
Yeah, good evening.
Sir, what is sunspot and how it is formed?
Okay, I've told little bit about the sunspots, but I'm not going beyond that because it's a very big topic, because we can't discuss in 1 hour all the parameters. But I'm telling little bit about what are the sunspots. Sunspots means the black spots, the black part of sun. We can see from this image there is a loop also, means there are two holes there. One hole is present here and second hole is present here, and these are called sunspots. Means from that part magnetic field lines escape from the surface of Earth, and these holes always form near the equator. There is a theory behind the butterfly diagram. You can go through the butterfly diagram. What is the butterfly diagram? Means there are around 22 years life cycle of sunspot. Means in 11 years sunspots is increasing in amounts, and next 11 years their polarity will change, and after that there is no sunspot, and then again one sunspot, sorry, two sunspot, four sunspot, and we'll get more sunspot uh, with respect to time. So sunspots mainly basically have lesser temperature than surrounding. So we can see if there is a surface have same temperature, but at some points there is a low temperature. So we will see the black spot there because that spot have low temperature. I've seen, I've told that these are the sunspots, means their temperature is low around
Sir,
as compared to their, sorry,
sunspot is formed by magnetic field of sun.
yeah, magnetic field lines of the sun. Yeah, from the point the magnetic field lines emitted from the sun surface, there is a sunspot formed there. You can also imagine the sunspot always form in pairs because there are loops formed because of magnetic field lines always. So sunspot always form in pairs, always, and near the equator also. Because as you can see in this image, the magnetic field lines distortion and different because of differential rotation, these sunspot form near the equator. Okay, initially in the time period of sunspot formation, the initially sunspot form at higher altitude, and after some interval of time, these sunspot will increase near the equator of sun, right? So I think you got your answer.
Yes, sir. Thank you, sir.
Okay, you're welcome. Anyone have more questions?
If someone has question to ask, they can put in the chat box also.
Yeah. Okay. So anyone? Anyone can ask any question.
You can unmute yourself
Don't
and
think
ask.
about.
Sir, can we see sunspot by binoculars?
No. Without any filter, you can't see sunspots. You can see sunspot by applying filter on your binocular also. And you can see sunspot by making a instrument from the paper also. You can make a paper of a black box, and you can put layers in that black box also, and you can see black spots on sun. But you can't see without any filter, because sun have a lot enormous amount of energy, and your eyes cannot uh, make it happen. Okay. So
Yes, sir.
by applying filter, you can see sunspot, but you can see sunspot around 2 to 4 sunspot in this interval of time, and there can be increase in sunspot by seeing from the telescope with some filter applying.
Sir,
But by
if we use mobile phone and set in binoculars, can see it.
Hello.
no, from the mobile phone you can't see, because mobile phone camera does not support this kind of things,
So
filters and all.
when I use, sir, sometime when I use my phone camera and set in my, I make small telescope. I use from mobile camera and I capture some sunspot.
Okay, you captured
Yes, sir.
how much amount?
But sir,
How many?
but sir, only sir one, but it is not clearly.
Yeah, that's the thing also, because we can see only one phase of our sun. Maybe the second sunspot is behind our sun, so you can't see that. So there can be three sunspot, as
Sir,
I
can
was
I ask
told.
you question in Hindi?
Yeah, you can ask.
Yes, Prakhar, you can ask actually, because we will be running out of time after 8 minutes. So please ask.
Yeah, please ask as soon as possible. Hello.
प्रखर आप हिंदी में पूछ सकते हैं.
Very good evening, Sanjay sir.
Yeah, very good evening.
Your presentation is too good, so informative and so nice. It's nicely planned and nicely explained. Salute to your efforts.
Thank you.
सर
Just
आवाज आ
I,
रही है?
हाँ.
just I want to say that I heard from someone that if you are using mobile cameras, it makes damage to your camera when you
Yeah.
when
That's
you take
also a
photos
part
outside.
in case of telescope also. If you see sun without any filter from the telescope, it can
सर मैं ये
damage the
पूछना चाह रहा
lenses
था
of
क्या
telescope also.
क्या अभी हमारे पास मतलब दुनिया में ऐसा कोई टेलीस्कोप है जिसके माध्यम से हम को सूर्य मतलब कोरोना को देख पाए?
या कोरोना को तुम वैसे भी देख सकते हो ना. कोरोना को तो टेलीस्कोप के विदाउट भी तुम देख सकते हो. सोलर इक्लिप्स के टाइम पे तुम देखना, जैसे ही सन जो है छिप जाता है मून के पीछे, so you can see the corona part also.
So
You
from
can
naked
see,
eyes.
तो जूम करके
no, you can see from the naked eye also the corona part when the solar eclipse in the time
For
of
very
solar
short,
eclipse.
for very short time.
Total
बहुत थोड़े समय के लिए.
only on the total solar eclipse. Remember the total solar eclipse time only. Okay, but you can use filter also to cover the sun surface, to cover whole sun, to see the solar corona part. You can see just so I think there is no image of solar eclipse here, but you can see. So see, this image consists of these lights also in the outermost layer of the sun. This is the corona part, chromosphere corona part. If you cover the whole sun surface, you can see this part only, this light only. This is the corona part, right? Hello.
Sir, I think you have cleared their doubt. Yeah, Chitra ma'am was telling something that time. Ma'am, you can continue.
Yeah. Yeah.
मैं तो सिर्फ
She is
यही कह
asking
रही थी
about.
कि जो टोटल सोलर एक्लिप्स होता है वो 7 मिनट्स का ही होता है। तो जैसे कि हम इस बच्चे
It
को बता
depends.
रहे हैं, ये बच्चा ही है मेरे ख्याल से, तो इसको जैसे हम बता रहे थे, तो मुझे शायद लगता है कि ये हमें बताना शायद जरूरी है कि भी 7 मिनट्स के लिए वो भी बहुत जो है बहुत थोड़े जो है इसमें
Yeah.
किलोमीटर्स में ये होता है। तो मतलब ये है कि बच्चा इसको उस वे में ना ले जाए, इसको बताने की बहुत थोड़े से समय
Yeah.
के पर 1 मिनट और लेस देन 1 मिनट वो सिर्फ उसको देखे, इससे ज्यादा नहीं
वही मैंने बोला कि it depends on location also. Solar eclipse depends on location also.
Yes.
So you can't see in total solar eclipse timing is very less. So you can see solar corona by covering the whole sun from any filter. From you can make any filter from your hand also. You can make any black paper filter also.